In this video, we're going to look at how we determine the equatorial coordinates of a star using the right ascension, measured in hours, and the declination, measured in degrees. Let's start by trying to work out the equatorial coordinates of the orange star here. Firstly, we'll start with the right ascension. To do this, you simply draw a vertical line from the star down to where it hits the axis. Here you can see it's exactly at 7. So this star has a right ascension of 0,700 hours. We can then do the same thing for the declination, this time drawing a horizontal line across to the axes, and you can see it meets at plus 30, so it has a declination of 30 degrees. Therefore, our orange star has a right ascension of 0,700 hours and a declination of plus 30 degrees. Let's look at another example. Here, our green star. Again, we're going to work out the right ascension by drawing a vertical line down where it meets the axes, and we can see that it's clearly at 9 hours. However, when we go to the declination, it doesn't meet perfectly. It's somewhere halfway between 30 and 40. Looking at it by eyeball, it looks about halfway, so we would say it has a declination of 35 degrees. So therefore this star has a right ascension of 0,900 hours and a declination of plus 35 degrees. Let's take a look at the yellow star. Again, we can do a similar thing for the right ascension, drawing a line vertically down. And here we can see that it's somewhere between 7 and 8 hours. However, it isn't directly in the middle. If we divide up the space between 7 to 8 hours, we can divide it into 60 minutes. We can see that this is approximately 2/3 of the way across, being closer to the 8 than the 7. And therefore, by estimate, I reckon it has a right ascension of around about 7 hours and 40 minutes. We can do the same thing for our declination. And again, you can see it's moving somewhere between 40 and 50 degrees. Being much closer to 50 degrees, I would estimate that this point here is approximately plus 48. So we can say that our star has the equatorial coordinates, right ascension of 0,7 hours and 40 minutes, and a declination of plus 48 degrees. Here we've got a similar problem, but we've zoomed in on the declination scale, so you can see we're only going up by 1 degree rather than 10 degrees each time. So let's have a look at this red star. We can work out the right ascension in a very similar way. Again, we draw a vertical line. Here we can see that we've gone past the first point of Aries, and that's why we've gone back to 0. So it's somewhere between 0 and 1. And again, I'd say it's approximately a quarter of the way across, so that would be 15 minutes past 0. So it has a right ascension of 0 hours and 15 minutes. When we look at our declination, again we can see that it's somewhere between 23 and 24 degrees, but it isn't directly in the middle. Again, between declination we use minutes, and there are 60 minutes between 23 and 24 degrees. Again, I would say it's about 3/4 of the way up from 23, and so that would be 45 minutes. So we can say that it has a right ascension of 0 hours and 15 minutes and a declination of plus 23 degrees and 45 minutes. Now that you've had a go at doing these, see if you can do the examples on the Kahoot, and good luck.